In this video, we're going to learn to write polynomial functions. More specifically, we're going to write cubic functions. The way we're going to do that is we're going to look at the graph and understand where the intercepts are and use those to start off by writing their factors. So in example 1, we're going to write the cubic function whose graph is shown at the right. The solution is use the given x-intercepts to write the factors. So I'm going to look at where the graph hits the x-axis, and I know I have a 0 at -2, which means, remember, the factor is of the form x minus that 0, which is -2. So really, x plus 2. And the other 0 is -1. So if we do x minus -1, it's really going to be x plus 1. And the final 0 is at 2. So if I do x minus that 0, it's going to be just x minus 2. Now, in the other section, we would just multiply all those factors out and we would have our polynomial function. However, in this case, we're actually going to go so far as to find the leading coefficient a. Notice they have an a there. To find a, it says substitute the coordinates of the fourth point. Guys, the fourth point will be any coordinate other than the zeros. You're already using each of the 3 zeros to write the factors. You do not want to use those again to find the a value. So we're going to use the fact that when we plug in x is 0, we get an output y equals -4. So what I'm going to do is I'm going to replace f of x, which remember is really just y, with the -4. I know that when I plug in the 0, I get out that -4, and instead of x plus 2, I'm going to write 0 plus 2. Remember, we're inputting 0 for x to get that output of -4. X plus 1 becomes 0 plus 1, and x minus 2 becomes 0 minus 2. Let's rewrite that a little bit out here. That means -4 will equal, now 0 plus 2 is just 2, 0 plus 1 is 1, and 0 minus 2 is -2. So we're really just multiplying a times 2 times 1 times -2. In other words, -4 equals, if you multiply those together, I think you get -4 times a. So if you divide both sides by -4, you're going to get an a value of 1. So to finish this off, our function, the final answer would be just x plus 2 times x plus 1 times x minus 2. Notice how I didn't write the 1 there. I don't need to. It's implied that it's a 1. So now it doesn't necessarily say to write this in standard form. So actually I'm going to be fine with you guys leaving it like this. If I do write to finish it in standard form, you would need to multiply out all those factors like we did in the last section. So it says for a quick check we can check the graph's end behavior. The degree of f is really 3, right? We have 3 factors with an x, and the a value is +1, so it's bigger than 0. So we never really talked about it in terms of this notation. What we did though talk about is the look of the graph. So if you remember, if the degree was odd with a leading coefficient that was positive, the end behavior looked like that. And if you take a look at your graph, it does match that end behavior. So that's a good idea to check, just to make sure you have at least the right sign of your a value. Let's do one more example before we give you one to try on your own. Okay, we're going to do one more example. I'm going to do this example 1 with you. We're going to write the cubic function of the graph shown here. So I'm going to start off by writing, okay, f of x is going to be some a value, that's our leading coefficient, and now let me write out my factors. I'm going to have x minus a -2, which is really x plus 2, that's one factor. Another factor is going to be x minus the -1, that's an x plus 1, and the last 0 is a 1, so that means I'm going to have an x minus a 1. I'm sorry, I have to write over the graph. I'll have to erase that for the next example. Now, in order to figure out my a value, I'm going to use this coordinate right here, which tells me, hey, when x is 0, I get an output, y, of 4. So I'm going to substitute in for y, 4. The a value is what we're trying to figure out, and I can very easily just put in a 0 for x, so it'll be 0 plus 2, and then I have a 0 plus 1, and a 0 minus 1. So if I just simplify that a little bit, I'll have 4 equals a times, and let's just see if we can do this a little bit easier, 2 times 1 times negative 1. I think that's just a negative 2. So if you divide both sides by negative 2, I get an a value of negative 2. Now don't leave this as your final answer, right? You want to put it all together and write, okay, f of x is going to be negative 2 times x plus 2 times x plus 1 times x minus 1. If I don't say you must write it in standard form, I'm fine if you leave it in intercept or factored form. Now, a quick check would be to say, alright, the degree, if we were to multiply all these x's out, we'd end up with a degree of 3, and the leading coefficient is a negative 2. And if you remember our end behavior, that would match with the graph that started high in the third quadrant and goes down, or excuse me, second quadrant and goes down forever into the fourth quadrant. And you can see our graph does follow that end behavior, going upwards in that second quadrant and going down to negative infinity in that fourth quadrant. So I feel confident we have this correct. What I'd like you to try now on your own is see if you can do this third example. Let me erase that off here. Do that third example and see if you can figure out the equation of the cubic function, and you do not need to write it in standard form, and we'll check it the next day. Good luck.